What you see here is the main controller board or main processor board for the electronic weather station that I've devised for students. And what it comprises is, there's 3 onboard microcontrollers on this board, 2 communication modules, some sensors and sensor interfaces. On this particular board here is designed to be part of a system that involves another weather station with the same processor board, as well as there's a companion website with companion web pages that process the data that is uploaded to that website, which is subsequently stored to a MySQL database. So we have these 3 microcontrollers. These are Propeller microcontrollers, that's the brand name, from Parallax Corporation. I really enjoy working with these processors, and the students have enjoyed working with them too, as well. This processor here is the central, or I guess I would call it administrative processor for the board. This processor communicates with the other 2, pulling information from them, and uploads that weather data to a website. This processor also communicates out back and forth through this radio frequency module, which is used to communicate with another weather station that has the same board. The remote weather station that this board would talk to would not have the Wi-Fi module. The remote weather station would only have this RF module. This board requires 2 voltages. This connector and this connector down here, 3.3 volts in, and this connector is a 5 volts in for some of the 5-volt circuitry on the board. This is a temporary power supply that I built in the past. However, now I have another version of it that uses switching regulators, and it's very efficient and also has the intelligence to be able to shut the system down. The intelligence and the ability to do that. This board communicates with the other circuit board through that connector right there. This connector is wired to this processor for programming this processor, but I also use the ports on this connector to communicate with the other circuit board, the timer regulator board. I'm not going to get too deep into this video because I want to just lightly talk about it, and then subsequent videos I'll give more detail about different sections. So anyway, what you see here, this is an altimeter chip or a humidity, air pressure sensor, which is used as for a measure barometer readings. This processor here communicates with that. I used a modified version of the routines that made by the manufacturer of these chips here. So this here is like I say, the barometer chip made by Parallax. Down here, this is a humidity sensor that's available through Parallax. A lot of stuff I've used from them because they provide routines and a lot of documentation and sample code that others can use to perform experiments with these devices. So this is a Sensorion humidity sensor, and also has the ability to measure temperature. Over here is an analog to digital converter, and that's used to convert the voltage levels from the anemometer, from the wind vane, to binary signals that this microcontroller can use and capture, and eventually upload to this processor, which will eventually output that to the internet. This circuit here is a real-time clock circuit that's powered by, has backup power from a supercapacitor. There's this crystal. All 3 of these processors have 5 megahertz crystals. They use a phase lock loop ability to turn that into effectively an 80 megahertz clock frequency for each of these three. And these are parallel processors. Each has 8 cogs. A can perform 8 processes in parallel, not multitasking. I guess I call that multiprocessing, right? So anyway, okay, I'm not going to spend a whole lot of time on this one right now. Just as a basic introduction of this board. The next video will discuss the timer regulator board. This is what I call the timer regulator board. There are at least 3 major features or functions of this board.